In this video, I'm going to show you some more examples of how to use the laws of logarithms to simplify expressions. Now, in these examples here, none of them have just numbers. They're all variables, and they have two or more expressions. So what I want to do is to show you how to express these log expressions as a single logarithm in its simplest form. And then I'm also going to show you how to find the restrictions on the variables. So this first one here, we have 3 logs, and they all have one variable each, and we're adding and subtracting. So when we add, remember that the values are being multiplied. So we can rewrite this as log x times y. And then because this is minus log z, the minus means that we are dividing the value. So the z will go in the denominator. Recall that the values that we log, x, y, and z, all have to be greater than 0. And this third question here is very similar to the first one, but notice that the second expression has a minus as well. So in this case, the m is positive, so it's going to be written in the numerator. And because we have minus log n, that's going to be written in the denominator, since we're going to divide. Now the second one is also minus log p, so the p value will also be written in the denominator because it's going to be divided. So this is going to be m divided by n times p. And again, there's only one variable in each of these log values expressions. So m is greater than 0, n is greater than 0, and p is also greater than 0. The third example here is a little bit different. So notice that we have some coefficients in the front of each of the log values, or the log terms. So what we need to do is take the coefficients and first rewrite it as an exponent. Now that we've done this, now I can combine our values. So we have log, I'm going to open up a bracket. The log a squared is positive, so that means it's going to go in the numerator. The minus log b to the half, this is a minus, which means that we're going to divide the value. So this will be root b in the denominator. And then we have a plus log c to the fifth, because we're adding, that means we're going to divide the value. Sorry, we're going to multiply the value, so the c to the fifth goes in the numerator, like so. So for all of these, we have a single variable again with no adding or subtracting with the variables. So we have a is greater than 0, b has to be greater than 0, and c also has to be greater than 0. Now before going to the last question, an important note about this one again is that before combining, to a single log, make sure that you move the coefficients. So move coefficients to the exponent. So otherwise we can't actually combine any of these terms together because they all have a different variable, and even though they have the same base, we can't combine them. So if we move the coefficients to the exponent, then now we have, we can use our log laws to combine the 3 log terms. All right, the last one here is quite different from the other 3. So we have log with a base of 2. And here we have a minus, which means we're going to divide. So we're going to have x cubed minus 25x dividing the value of x minus 5. Okay, so I'm going to keep simplifying. I can factor out an x in the numerator to get x squared minus 25. And then the x squared minus 25 is a difference of squares. So this will be x times x minus 5 and x plus 5. So all of this is divided by x minus 5. So here we can cancel off the x minus 5 to give us log base 2 and then in square brackets x. Oh, I don't need this round one. So we have x, and then times x plus 5. Now, when we find our restrictions, we have two expressions to look at. So here we have the fact that x minus 5 has to be greater than 0. So x is greater than 5. The other expression says that x cubed minus 25x has to be greater than 0. But I'm going to use the factored form, which is right over here. So I'm going to use that x times x minus 5 times x plus 5 has to be greater than 0. Now, if you recall pre-calculus or calculus, or sorry, math 11 from last year, we need to split this up by finding the zeros. So the zeros in this case will be 0, 5, and negative 5. And what we're going to do is we need to test 4 values, one from each interval, to see if this will give us a positive or a negative value, ignoring this greater than symbol for now. So when we plug in negative 6, we notice this is negative, and this is negative. So we get 3 negatives. When multiplied together, we get a negative value. If we pick a value between negative 5 and 0, let's say negative 1, this is negative, this binomial is negative, but the second binomial is positive. So negative times positive will give me a positive value. We choose 1 times negative 4, so a positive times a negative times a positive will give me a negative value. And then the last interval, let's pick 6. 6 would make this positive, the second binomial positive, and so is the third. So we are looking for values where it's greater than 0, and this occurs when x is between negative 5 and 0, and also when x is greater than 5. So these are the two restrictions for the first expression, and x greater than 5 is for the second expression. However, we need to take a look at them overall. So since the second expression says that x has to be greater than 5, we can't say that x can also be between negative 5 and 0. So therefore, my only restrictions is that x is greater than 5, because we can say kind of, I guess it's more restrictive. Okay, so overall between the two expressions, or the two restrictions, the x greater than 5 is more restrictive compared to having both of these restrictions here.